Today we're going to be dealing with more complicated ways to use the 30, 60, 90, and the 45 and 45, 90. On problem number 5, it's going to ask us for what the surface area of this whole pyramid is. Okay? So I want you guys to understand that the pyramid is formed of 6 isosceles triangles. I'm just going to shade in one. I'm not going to shade in all of them. I'm just going to shade in one. And this isosceles triangle has a specific area. All right? The area of a triangle is always the formula 1/2 base times the height. Now there's other formulas for the area of a triangle, but this one is what you're typically used to. All right? So if we did the formula for the area of this one particular triangle, we could call this distance the base, which is 6. All right? And even though they didn't draw it in, they drew it in right over here. What's the height of this triangle going all the way down? 12. So if we say half of 6 is 3. 3 times 12 is 36 inches squared. So if you multiply an inch times another inch, that's where you get what's called a square inch. No, not a square root, a square inch. Now, this particular answer right here is the area of how many of the triangles? That's the area of 1. So how many of them do we have? We have a total of 6. Yeah, so what you're going to need to do to find the area of all the triangles that surround this hexagon, okay? You have to multiply it by 6, and that's going to give you a total of 216 inches squared. Now that's not my final answer. That's simply the answer of all the area of the triangles. So we have to find the area of the what? The hexagon. So guys, to make it a little bit easier, can you guys remember to hold on to that answer because we're going to add it to the answer of the hexagon. So I'm going to zoom in on the hexagon so you can see it a little bit clearer. Okay? So right now, there is a special quality about all regular hexagons. All right, and here's the quality. If you draw a diagonal, the diagonal, the diagonal. I want you to know that inside of a regular hexagon, every single one of these triangles is actually an equilateral triangle. So I'm going to focus in on just one of them, not all of them. Let's just focus in on an easy one to look at. I'm going to zoom in on I'm going to shade it a little bit right here. So let's just focus in on just the area of this particular triangle. Now, there is a formula, for those of you who are watching the video, you're like, dude, why aren't you using 1/2 the apostrophe times the perimeter? Because we haven't gotten there this far. So right now we're just going to focus on just the area of that triangle, and what are we going to multiply our answer by once we find that area? We're going to multiply it by a total of how many of those triangles are there? 6. So once again, we're going to multiply it by 6. We're going to find the area of this one triangle right here. So right now, you see what it says 6 inches? That 6 inches means it's the distance from right here to what? Right there. So if you would, please. I know it's kind of hard to on your paper, but if you wanted to, you could write a 6 right here, a 6 right here. I'm going to go down. And this distance is also a 6. Now, right now, I'm going to give you guys a shortcut to find the area of every single equilateral triangle that has ever been created. So let's just pretend that S represents the side of the equilateral triangle. So but S equals what? S equals the length of the side. Now, knowing that an equilateral triangle has 60-degree angles in every single corner, and knowing that the area of a triangle is 1/2 the base times the height, what would be considered the base of this particular equilateral triangle? What's the base going to be equal to? Like, what symbol did I say the base is equal to? S. So just put in 1/2 S in your journal. 1/2, we'll put S. And what does S once again represent? S equals the length of the side. So make sure I put double tick mark, double tick mark, double tick mark to let you know that all those sides are indeed congruent. Now, what I'm going to do next, I'm going to highlight the H in this awesome green color. And I'm going to draw in the height so you guys know that right there, that's my height. I'm going to put H. Now, ooh, what happened right here? That cut that 60 perfectly in half. So that's what? That's 30. Oh, that's 60. That's 90. So right now, I'm going to write a 30, 60, 90, X, X. Right, 3, 2x. This is something you should already know. This is where it gets a little bit tricky. Does everybody see that this right here is indeed my 90-degree angle right in there? Okay. The side that's directly across from the 90-degree angle in this particular case is the length of my side. Okay. That's the length of my side. So if this right here, if this has been multiplied by 2, then this 30-degree side is going to be whatever that value of S is divided by 2. So make sure you guys are writing the letter S and you don't mistake it for the number 5. I know you probably wouldn't, but sometimes students do that. So right here, what is this little side here? This is going to be actually what's called, what? Half of what? Half of S, that length from here to here. So what would the height be? I'm going to change color. What would the length of this height be? It's going to be S over 2, right? Times a what? Times a radical 3. So I'm going to put right here S over 2 radical 3. So what is going to be the length of my height? The length of my height is across from what angle? It's across from the 60-degree angle. So I could always put an S radical 3 all over 2. So what is my final area going to be equal to? What's going to be the shortcut that you can have in your journal every single time you come into contact with an equilateral triangle? You're going to say it is, what is a half times another half over here? Think long. What's S times S? S squared. All right, so what's the numerator? 1 times an S times another S, which gives me an S squared. What else do we have? We have a radical 3. And what's this all over? What's 2 times 2? That's going to give me a 4. So there's your shortcut. S squared, radical 3, over a 4. Now we're going to test. We're going to test this formula out with this particular problem. We're going to test it out. So here's your shortcut. All right? I'm going to go up here. What's the length of our side? 6. Ooh. So let's just use it. Yeah, so let's plug it in. Right here, what's our side? 6. What's 6 squared equal to? 36, good. So here's what I'd like you to do. You're going to put 36 radical 3 over 4. Does 4 go into 36? Yeah, how many times? 9 times. By the way, everybody, this is the area, okay? That is the area of how many of those equilateral triangles inside that hexagon. That's the area of one of them. Very good. Now, if that, by the way, if this shortcut right here that you can have in your hair, right? If this shortcut doesn't make sense, let me show you that we get the exact same answer if we just do it the long way. Okay? So watch this. We're going to do it the long way real quick. So we'll just keep going. You can catch it. All right. Right here, what's that length called? That's the one of the triangles. Height, right? So by the way, if I take this and I make this a 30, 60, 90. If that's a 6, what is this length right in there? That was a 6, that's a what? That's a 3. And what does this become? This becomes a 3 radical 3. Now, understand, we're doing the properties of a 30, 60, 90. If that doesn't make sense, just write down, what's the length of our hypotenuse? A 6. What's our shortest side? A 3. What's our height? 3 radical 3. So if I did the old-fashioned way of finding the area of a triangle, which is what 1/2 base times the what? 1/2 base times height. What is our base equal to? 6, right? All the way across is what? All the way across is 6. What's our height equal to? 3 radical 3. What is 6 times 3? 18. What's half of 18? 9. So by the way, if you did it the old way, like the old-fashioned way where you just find all the sides that you need, what answer do you get? 9 radical 3. If you do the shortcut, what do you get? 9 radical 3. So let me go back to the original problem, okay? Back to the original problem. This is what we did. We zoomed in on this, right? What did each one of these little tiny triangles, what's the area of each one of those? 9 radical 3 inches squared. How many of those triangles do we have? Make you let us know we have a total of what? 6 of them. So I got to take that and I got to multiply it by 6, which gives me a 54 radical 3 inches squared. So what am I going to have to do now that I found the area of not just one of the triangles, but I found the area of all of them? I have to take this number and I have to add it to this number for my final answer. So it says, what is the surface area of the pyramid? We add those two together. So you take, let me get out of this real quick. Clear out. All right. So we take 216 and we add it to 54 radical 3, and that gives us our final answer. Our surface area of this pyramid, the surface area, is approximately equal to 309.5 inches squared. And how did we add, what did we add together? This would be your exact answer. Okay? That's your exact answer. You can't add these together because those aren't like terms. Okay? But this is your approximate answer for that problem. We're going to continue to move on and try to give you as many examples as you need to make sure that you guys understand. Oh my goodness, you know what? Let's not even go to number 6. Let's just go straight to number 7. Let's go straight to number 7. Check this out. Why do I want to go straight to number 7? It's an equilateral triangle. And what are we trying to find the area of? The triangle. Now, by the way, did you write the formula down? Did you write the shortcut for the formula? No? Okay, you here write the formula down? Oh, Alex, what did you write down for the area, the shortcut for the area of an equilateral triangle? What did you get?
S squared radical 3 over 4.
Oh my gosh. So if we just know the length of the side, we could find the area of the triangle because this side is equal to this side, which is equal to this side.
So we just divide 57 by 3.
Yeah. Take 57, divide it by 3, and what's that going to give us? 19 centimeters, 19 centimeters, and 19 centimeters if I divided 57 by 3 accurately. Okay? Is 19 times 3 equal to 57? I sure hope so. Otherwise, that would be embarrassing. Okay? So, right now, what number is the only number that you have to literally plug in to find the answer to this problem? By the way, this could really be helpful right here. If you memorize that formula, then every time you saw an equilateral triangle and you had to find an area, you could use that formula and find the exact area every single dadgum time. Yeah, but you know what? Did you write it down yet? Good. So right now, you better put this. You better put 19 squared radical 3 all over a 4. Now, how do you type that in the calculator without messing up? Let me show you. Oh, hold on. Do alpha y equals enter. All right? Open that up. Alpha y equals n. It's really cool. And we're going to square it. Then I'm going to type in a radical 3. I'm going to go down, and I'm going to hit the number 4, and voila, there's my answer without having to do a whole bunch of long, ridiculous work. What's my answer equal to? 156.3. I think, is it centimeters or inches? Centimeters squared. Now that's the shortcut. All right? So for those of you who you don't like the shortcut, you're like, the shortcut's just not going to work for me, Mr. DeMude, that's okay. I'll quickly show you how to find the height of this triangle. All right? You just use the properties of a what? 30, 60, 90. X radical 3, 2x. This time our 2x side is 19. Half of that is 9.5. And the 60-degree side is 9.5 radical 3. So what if I wanted to use the formula, area of a triangle? Like, I'm not going to memorize that, and I just want to use 1/2 base times height, because that's the type of guy or gal I am. What's the base of my triangle? 19. What's the height of my triangle? 9.5 radical 3. So I'm going to type this in the calculator so you guys see the exact same answer if you didn't use the shortcut. So I'm going to write 1 divided by 2, parentheses, what was the base of the triangle? 19. And what was the height of the triangle? 9.5 radical 3. Boom. Oh, hold on. So this and this end up becoming what? The exact same answer. Okay. Oh, now the exact answer, just so you know what the exact answer would be, 19 times 19. All right, is what, 361? All right, so the exact answer would be 361 radical 3 over 4, because 4 doesn't go into 361. So this would be the exact answer in centimeters squared. So this would be, if you were not given approximate, if it didn't say what's the approximate, say what's the exact, this would be the exact answer, because 4 doesn't go into 361. Right, so it says approximate, so we just use the approximate. Okay. All right, moving on. Oh, look at the cube Dylan drew so precisely below. We have a cube. What's a cube made up of? What are the faces of all cubes? The faces are squares. Which triangle deals with a square? Which one? The 30, 60, 90 or the 45, 45, 90? 45, 45, 90. Check this out, everybody. I want you guys to know that this distance right here is 24. This leg right there and this leg is part of what type of triangle? The 45. So put 45, 45, and then put a 90 right there. Just draw that in. All right, what I'm going to do right here, everybody, is I'm going to write 45 degrees, 45 degrees, and 90, what I'm going to do is I'm going to write it in green, because the 90-degree angle is directly across from the green side that I highlighted. Okay? And then I'm going to write an X and an X. And then I'm going to write X radical 2. So right now, everybody, what I'd like you to do is realize that my hypotenuse of this right triangle, the hypotenuse right now is equal to a 24. Now, how in the world am I going to go from a 24 to finding my x? So here's what I want you to write. Solve for x. There are 2 simple steps that you can use to solve for x. All right, step number 1. What you're going to do is you're going to take half your hypotenuse. Take half your hypotenuse. So I'm going to do that in parentheses right here. Okay? So right here in parentheses, I'm going to take half of 24. And half of 24 24 gets me what? It gets me a 12. Okay? So the next step, here's the next step. I'm going to take that number. Take that number, and what's the number that I'm going to take? I'm going to take that number, which is a 12, right? All right? And okay, we're going to take that number, and we are going to take that number and multiply it. Ready? Multiply it being the 12, by radical 2. So when I take the 12, everybody, and I multiply it by radical 2, I get the answer 12 radical 2. And that answer is what x is right here. So you're going to write 12 radical 2 and 12 radical 2. Okay. Now, what does that mean? That means this side right here is what? 12 radical 2. What is this side? 12 radical 2. What about this side of the cube? That's 12 radical 2 as well. So right there to there is also what? 12 radical 2. No, but 12 radical 2. Now why is that important? Because this right here, you could call this the width of the rectangle, and you could call this the length of the rectangle, and now you have the two dimensions that you need in order to find the area of the rectangle. So right now, right, we're going to write area of a rectangle is equal to the length times the width. Well, what is the length of the rectangle? They gave it to us, right? It's a 24. And what is the width of the rectangle? 12 radical 2. Now, what is 24 times a 12? I believe it's 288 radical 2. Now, that will give us an approximate value. Now, by the way, everybody, I'm going to put this in inches squared. This part right here is considered to be your exact answer. That's your exact answer. Your approximate value would be 288 radical 2, which gives you approximately 407.3. 407.3 inches squared. This is how many inches squared. That's what's called your approximate answer. So there's your exact, there's your approximate. What instructions do you need in order to find x in a 45, 45, 90? You take half your hypotenuse and take that number and multiply it by a radical 2, and voila, you're done.
So let me one. I don't remember writing this, but I'm extremely glad.
All right. Everybody, can everybody see this? Oh, it says what? Look at this right isosceles triangle. All right? Now, what is a right isosceles triangle? There's only one of them in the world. 45, 45, 90. And we're going to put x here, we're going to put x here, we're going to put x radical 2 right there, because where's that directly across from? The 90-degree angle. Something you guys need to know about all triangles. When you have to find the area of a triangle, you always need the base and the height, but what are the base and the height always connected by? They're always connected by what type of angle? A right angle. So you guys, by the way, you could call this side the base, you could call this side the height. Wait a second. Could I call that the base? Sure. Can I call that the height? Sure. As long as they're connected with a right angle. So everybody, I want you to understand, our final answer is going to be 1/2 the base, which is x. That's 4 blocks. Times the other value for x. So what do you have to solve for? You got to solve for x. What's the only piece of information? TL is what? 42. So everybody write it down. 45, 45, 90. X, 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 radical 2. Here we go. What in the world is my 90-degree side in this particular case? 42, you are right. Right, it's 42. Now, Colin, do you remember the 2 steps? Like, if you could say them out loud, and we'll do them. We won't write them all down. I think you've probably written them down. What are the 2 steps? What's the first step?
Take half your hypotenuse.
What's half that? You got it? Doing good? 21. So put 21 here. All right? Put 21 here. Now we're not done. That was the first step. Take what? Take half. Then what do? What's the second step? After you take half of it.
Take that and multiply by radical.
You multiply by radical 2. Guess what you just found? You just found your, well, you found the pieces of information that you needed to do what with? To plug in here and to plug in there. Because this distance and this distance, both in this particular case, are what? 21 radical 2. And what's this one also? 21 radical 2. So let me show you how it's done. You do 1/2 21 radical 2 times 21 radical 2. Now you can type that all in the graphic calculator if you want to. Watch this. Check this out. Does anybody know what 21 times 21 is equal to? 21 squared. 21 times 21. 441 is right. 441 is right. Does anybody know what radical 2 times radical 2 is equal to? Radical 4. Well, what's radical 4 equal to? How about this? Ready? Watch. Let me show you. Radical 2 times radical 2 equals 2. If you take a radical of any number, Alex, and multiply it by the same exact radical, it's just whatever the number is inside. So what is radical 2 times radical 2? It's just a, no, it's just a 2. Radical 2 times radical 2 is just a 2. Oh, one more. Ready? Radical 3 times a radical 3 would just be a 3. How about this? Radical unibrow face times radical unibrow face is equal to unibrow face. There we go. All right, so right now, what's half of 2? 1. So our final answer is 441 inches squared. All right, so HE has a secret affinity for circles. I'm glad. Yeah? So it's always good to have an affinity for circles because circles are everywhere. And whether you like it or not, they're everywhere. All right, you should be thankful that your cars have. Yeah, that's going to help you get to the places you need to go. All right. So right now, in this figure, we have to find the approximate length of what? L to T. So if you would please realize that we are going from L all the way to T. All that distance. That's a long way to go. All right, long way to go. Now, I want you guys to look at 2 triangles, okay? We've got a triangle right here, okay? Coloring it red. And here's the other triangle I'm doing in green. Go green. All right. Okay. Now, these triangles, I know for a fact, have equal lengths because they're inside of a circle. So I know that this distance has to be the exact same as this distance because the radii of the circle are always equal. All right? And so that has to be a what? 45, 45, 90. So right here, I'm going to write 45, 45, 90. I'm going to write x, 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 radical 2. Sound effects free. What is the distance of my hypotenuse in this particular red right triangle? 8 radical 2. Can I work my way backwards? What do these have to be? They both have to be 8. So this was the easy one, right? Okay, this was the easy one. So what does that have to be? That has to be in 8. Oh, interesting. What do y'all think this distance is right from here to right there? 8, very good. So what do we know for a fact? We know for a fact that the distance from L to P, right now we know the distance from L to P is a total of 16 units, right? That's the distance from L to P. Now this one is another what? It's another 45, 45, 90 because this radius has to equal this radius. So what do I write? 45. 45, 90, x, x, x radical 2. Now Colin, this is the trickier one, right? Because what's our 90-degree side? Our hypotenuse is now a 20. But you gave us 2 wonderful steps last problem. What did you say? What were those 2 steps? Take half of it, which is what? 10. Put a 10. And what else do I have to do after I take half? Multiply by radical 2. So that's going to be 10 radical 2, and that's going to be 10 radical 2. What does that mean? That means this is 10 radical 2. That means this is 10 radical 2, which also means that the distance from R to P is 10 radical 2. Now, are these like terms? Can you add those terms together? Absolutely. If I have 10 radical 2s and I add another 10 radical 2s, how many total radical 2s do I have? 20 radical 2s. Which is your distance from what? P all the way to what? From P to T is a total of 20 radical 2 units. Now it says, what is the approximate length of LT? What are you going to have to add together? You're going to have to add 16 plus 20 radical 2. And that, right there, 16 plus 20 radical...
36 radical 2.
No, think we're playing. Now, understand, you can't add those. This is right. This is your exact answer. This is your approximate answer. So your approximate answer is 44.3. What was the unit? Was the unit in just units? That is units. No, they're good units. I don't think there's feet or inches or anything like that.
No, I don't see.
So this is your, by the way, I want to make sure you understand what you are not allowed. This is not going to become. This is not equal to 36 radical 2. Now, check this out. If I said 16 radical 2 plus 20 radical 2, then it would be. So this is not equal to 36 radical 2. But hey, you know what? Honestly, I'm glad you said that because, listen, lots of people in America might accidentally do that. Okay, so you're one of them? Okay, remember, you can't add these together unless they're like terms. So you could add 16 radical 2 plus 20 radical 2 to make that 36 radical 2, but that's not what our answer was. Okay? So that's not right. Our answer is 44.3 units. Okay? Alright, here we go. Problem number 18, it says ABCDEF is a regular hexagon with a side length of 8 inches. What is the area of this particular rhombus? Okay, so we're going to find the area of this rhombus. Now check this out. Take that rhombus and cut it right there. You know what kind of triangle that is? An equilateral. You know what kind of triangle that is? Equilateral. So by the way, what are all the sides on that equilateral equal to? An 8, an 8, and an 8. Wow. If there was only a formula that could help us find the area of just one equilateral triangle. Does anybody know that formula? S squared. Radical 3. Wow. How many of those do you have? 2. So if you wanted to, you could take the number 8, plug it in, square it. Then, if you want to, you can multiply it. Eventually, at the very end, what do you do? At the very end, multiply by 2. So right now, what am I going to plug in for S? I'm going to plug in an 8. What am I going to do? I'm going to square it, which gets me a what? 64. Radical what? Radical 3 all over a 4. Does 4 go into 64? Absolutely. It goes into 16 times. By the way, this is the answer for one of them. It's not the answer for both of them. So this right here, everybody, this is the answer right here for one of the triangles. You need to take this answer and do what with it? Multiply by 2. And that's your answer for the area of what? Both of them. 32.
Oh, 30.
Radical 3.
Oh, yeah.
So if you take 2 and you multiply it by 16 radical 3, that becomes 32 radical 3 inches squared. So all you got to do is do 32 radical 3. Boom. 55.4 inches squared is your answer. 55, did I say 55.4? That's your approximate answer, 55.4 inches squared. If you choose not to do any more problems and turn that in on Monday with those not done, it will severely impact your grade. So your job is to do the rest on your own. Good luck. By the way, if you work really hard, I will answer a couple of questions on Monday if you can't quite figure them out. But don't come back with a whole bunch of blank pages.